teaching today. Okay, here we are. Everybody look up. We're doing 62B. And this is a section that I see a lot of errors on, even though it's a very simple section. Okay? We're talking about the difference between linear variation and direct variation. Okay, what is direct variation? What have I always told you your equation for direct variation? Y is kx. All right. So basically, if y is kx, isn't that k going to be the slope of that line?
Yes.
All right. So a direct variation is simply a linear variation that has no y-intercept, meaning it goes through 0. 0, 0. Okay? But a linear variation, which we're starting to talk about now, is simply a line. Okay? Where we're saying this thing relates linearly. So let's look at the problem. There's only one problem example in the book, and it'll only take a few minutes. The total cost varied linearly with the number produced. Okay, so what can I say? I can come over here and say the total cost, C, varies linearly, so I'm using this form. Okay, where I'm going to go mx plus b, but instead of the x, which is my usual input variable, they're saying that the cost varies linearly with the number produced. In other words, I should be able to put the number of produced in there and get the cost out. All right, then it gives me some information, just like it would do on a direct variation problem. It says when 100 are produced, the cost is 700. When 100 are produced, so I'm going to put 100 in here for my input variable. 700 is the cost. And then it gives me another one. When 400 are produced, 2,200 is the cost. So 2,200 is the cost when 400 are produced. So we have two linear equations with two unknowns. Can we solve? Okay, can we find out what the slope is? Can we find out what the y-intercept is? By plugging in these 2 points that they gave us. Yes, we can. So what we're going to do is get something to eliminate. Now right now, the b is all set to eliminate if I just make one of these negative, right? So since this one's bigger, why don't we just make this one negative? So we're going to multiply everything by negative. Negative, negative, negative. All right? So now I'm going to add them together, and what do I get? 0, 0, 15?
Yes.
Okay, is equal to, now these are not going to cancel, but this is going to be what? 400 minus 100m, which is going to be 300m. And my b's cancel. Can I solve for my slope? So my m, which is my slope, is going to be 5. All right? So now I can go back to the top of my equation in one of these others, and I can plug in 5. Now I already know that my 5 goes there. I'm trying to come up with this equation is what I'm trying to do. Now I got to go find my b. So I'm going to go back up here to one of these equations, and I'm going to plug in my 5. All right? So I'll just use this one because that one already had a negative through it. So I've got 2,200 is equal to m, which is 5 times 400 plus b. All right, so this is going to be what? 2,000 plus something is 2,200. So what's the b? b is 200. It has to be 200 to make it fit. Now be smart to put both of those into this one, just to make sure that I don't have any problems. So if I did, even with my minus driven through, bless you, if I put my 5 here, and I put my minus 200 here, does it work? I get negative 700 is negative 500 minus 200, bless you, and it works. Okay, that is linear variation. All you're going to do is start out with your slope-intercept form and plug in points. Okay? If it says it varies linear.